In simplified terms, retrocausality or backwards causation is a concept highlighting that an effect may temporally precede its cause, suggesting that a future event could influence a past one. This concept blurs the lines between cause and effect, particularly in quantum physics, where systems can be seen as either causal or retrocausal. Although this idea is potentially linked with time travel, as both delve into the manipulation of time, they are distinct concepts. The heart of philosophical argument remains to understand causality, a dialogue echoing back to Aristotle's exploration of the four causes. Traditionally, it was believed that an effect cannot precede its cause because, as highlighted by 18th century philosopher David Hume when examining two interconnected events, causality is defined by the first event which sparks the subsequent effect. However, this long-standing viewpoint was challenged by Michael Dummett in the 1950s, who believed there were no philosophical boundaries limiting effects from preceding their cause. His position was rejected by fellow philosophers Antony Flew and Max Black. The latter held that retrocausality is impossible as the observer could intervene to restrict its future cause from occurring, an argument further complicated when examining the interplay of free will. This concept could potentially introduce logical contradictions, such as the grandfather paradox, where a cause could be undone by its own effect. However, such paradoxes are not inherent in the concept of retrocausality or time travel. As long as the boundaries of time travel are carefully defined, certain elements in modern physics like hypothetical tachyon particle and time, independent aspects of quantum mechanics might permit particles or information to travel backwards in time. While the macro-level scenario often faces logical barriers, retrocausality might still hold up at smaller scales of interactions, however. Even if permitted, they may not necessarily create different outcomes from regular causal relationships. Closed time-like curves, a situation where an object's course circles back to its starting point, emerge from some accurate solutions to the Einstein field equation. Although such curves do not tend to exist under normal conditions, certain extreme space-time environments may allow their formation, suggesting the possibility of retrocausality. However, the material or topological defects required to create such situations have not yet been discovered. Moreover, as per Stephen Hawking's chronology protection conjecture, these curves would likely be destroyed before they can be utilized effectively. Retrocausality plays a crucial role in quantum mechanics, featuring in the two-state vector formalism, where the present state is defined by the past and future states simultaneously. The idea expressed by Wheeler is that all electrons share the same properties because they are theoretically one electron with a complicated self-crossing path in space and time. Yoichiro Nambu expanded on this by applying the same idea to the creation and destruction of antiparticle pairs, arguing that their creation or annihilation is not a direct cause and effect, but rather a redirection of their movement either from past to future or vice versa. While this perspective, viewing events backwards in time, is considered valid, it would be inaccurate to equate it with macroscopic terms of cause and effect due to their absence in microscopic physical description. Retrocausality, or the idea that an effect can occur before its cause, is often linked with the correlations derived from quantum entanglement. Still, explanations of quantum entanglement don't necessarily require retrocausality. Instead, it's considered that different reference frames could describe the experiments, providing different views on what's considered the cause and the effect. These varying interpretations hinge on the observer's perspective, suggesting a relative instead of an absolute distinction between cause and effect. Quantum entanglement, however, can still be analyzed without retrocausality, especially when considering the states of the system involved. John G. Kramer has delved deep into the prospect of retrocausal quantum communication. However, his findings reveal that no flawless solution exists. This aligns with the no communication theorem, which asserts the impossibility of signal transmission via non-local means. The concept of quantum gravity entails harmonizing the principles of both relativity and quantum physics. Some theories suggest that the classical notion of a causal structure, a cause always preceding an effect, is impossible in a framework that incorporates the principles of quantum mechanics and classical general relativity. A Bell-type theorem has been proposed as a potential experimental test of a potential experimental test of this theory. In science fiction, tachyons are usually portrayed superluminal particles that can seemingly travel back in time. However, this phenomenon doesn't defy the standard causality, as the tachyons don't interact with regular tardionic matter to facilitate information transmission. The Feinberg reinterpretation principle further explains that a hypothetical tachyon detector utilizing ordinary matter would not be capable of receiving information. In the experiment, participants were shown two sets of curtains and asked to speculate which concealed an image. However, the hidden picture was only revealed post their speculation. Interestingly, when it came to guessing the location of erotic images, a segment of participants who identified as stimulus, seeking in the initial questionnaire, had a notably higher success rate EPS-17. Nevertheless, this researcher faced similar criticisms as earlier researchers in terms of credibility and accuracy of methods, leading to his results being largely dismissed.